All right, I guess I'll try this microphone. Good evening. Thank you all for staying. I guess I didn't realise when I submitted a paper that I'd be speaking this late, so I'm very happy that you're all staying because it's been a long day as well. My name is Ronald Bradford, and we have a very short time to talk about my views on performance architecture. So I'm going to run through a few points as highlights, and hopefully that might come a gem or two that you may be able to use in your existing environments. What I want to look at is just a few points. We only have a short period of time. It's very awkward talking by leaning forward too much. I've just got a few categories, and I want to either give a few examples or a few tips that I've come across from my time looking at various websites. My background is MySQL performance tuning, architecture, and large systems design. I do this as an individual, independent person. My background is with actually working for MySQL and their professional services. So I've seen plenty of horror stories in my life. So I want to talk about technology first. For those who attended the closing keynote this evening about the Obama campaign, it was a very apt point to talk about my first point, which is regarding to technology. Once you've chosen a piece of technology, understanding and how to use that technology and using domain experts to maximize that technology is a good way to ensure success of your business. So using generics is inefficient. If you've chosen MySQL but you have an Oracle data architect, then that Oracle data architect is going to make the mistakes that Oracle data architects make when using MySQL. You need to look at maximizing the strengths of the product and minimizing the weaknesses of the product. And the presentation this afternoon, I don't know how many people attended the closing keynote. Okay, a few of you did. I was disappointed to see these beginner mistakes that they were making in their site, and then they would continue to make further beginner mistakes. So you don't have to hire a full-time person to be for example, your MySQL architect, but leverage an expert. When you're looking at configuring your web servers in load balancing situation or handling high load, seek a person who's an expert in Apache configuration. Get those people to help train the staff that you have.
Hey Ronald, you're a little too close to the mic.
I'm too close to the mic?
Yeah, I think
Is that better?
Yeah.
I'm sorry. See, you're all too slow. It took you so long to tell me. Thank you. I thought I had to be closer. So, as I've said there, in this case we're talking about MySQL. If you've chosen MySQL, maximize the strengths of the product and minimize the weaknesses of the product. So moving right along, because we have quite a lot of topics to talk about. One thing that I focus a lot on is disk, and if you were here this morning, Carrie talked about disk not being the most important consideration for physical resources. Disk is the slowest physical resource, so it's one of those things that you want to focus on. It may not be the only thing to focus on, but you want to actually focus on certain things. So I have a very simple equation, and that is disk equals memory equals performance. The less disk accesses that you can perform, which means the smaller disk footprint that you have, means the more data that you can put into memory, which means the greater performance you'll have in your system. It's as simple as that. So, what is poor disk performance, for example? It comes down to the design of your database. If I go to a client and I see any of these examples, then it's an indication of the schema being less than optimal. And if anybody has those in their schema, want to admit that they have any of these sort of considerations, defining int as a display length of 1, using big int or not using unsigned. My favorite is decimal 31. So let me give you a few examples of what I'm talking about. Here is an example of a table where big int was used, and I only made one change, and that was to change the columns of big int to int. That's the only thing that I did. I took a big int column, which is by default 8 bytes, and I converted it to an integer column, which is 4 bytes. An int unsigned column stores a value to 4.3 billion. So unless it's a column in which you're calculating values, in this case they were actually foreign keys. What happened was there was a 33% reduction in the table by just simply changing, I think, 4 columns in this expression. That's all I had to do. So that alone, cut the size of the file down. Here's an example of a for an environment where the tables were in the hundreds of gigabytes in size. And I made one change because they had learned from a training person that char was a better indication of columns than varchar. And by changing a column from char 128 to char 20, actually I think it was char 30, char 20, char 30, because their data only contained values of that size, I reduced the size of the footprint of the file by 60%. And this was an example where this database was 300 to 400 gigabytes in size. And that's a significant saving. Actually, I think it says 600 there, so maybe it was bigger than I thought. Here's the best. 84%. I've reduced the disk footprint in this table by 84% and the entire database schema by 78% by changing one column. That column was decimal 31,0, which people might ask, where does that come from? Well, that comes from people thinking they know about Oracle and using MySQL. And what was ironic in this situation was they had a well-sharded application, and I was able to take their database, which didn't all fit in memory, and put their entire database in memory by making one change. So in this case, looking at your schema and understanding what things can be improved. We talked about int1. Int1 doesn't mean 1 byte, int1 means 4 bytes. So these slides will be available later on my website. So in the order of keeping up to date with time, we'll move on. I talked about big int as well. There's no need. When people have big int as an order increment column, unless you're storing more than 4.3 billion rows in a table, which you shouldn't be because you should be partitioning it out, it's never necessary. And if you have 4 or 5 foreign keys and then indexes on those, huge savings. I should stand back, shouldn't I? Is that better? I'm sorry. Just keep, throw something at me. It's been a long conference. So we talked about disk. Disk is the slowest resource. And I also mentioned memory is important. So what do you do in an architecture to maximize the use of memory? Well, it's very simple. Don't waste it. Doing a select star, using UTF-8, using text blob columns excessively, and using large per session buffers are all things that unnecessarily utilize memory, and you can cut down on those things. Character sets is a really good example. By default in 5.0, the UTF-8 is the default character set. So that may seem okay on disk, and it is on disk, it's optimal. If you have 4 bytes in a varchar field, then the size on the on disk is 5 bytes. 4 bytes plus the size of the field. When you put that in memory, okay, with using a temporary table, which is used internally in some type of operations of SQL statements, varchar 255 actually becomes 255 times 3. So when you have a table like this, that's not optimal design. First of all, I hate varchar 255. It's an indication of 2 things. 1, no one's considered design, and 2, they're living in MySQL 4.0 world, or 4.1 world. So this is a good example to say that we need to do something about improving this. With columns that don't need to be varchar 255 to start with, and they don't need to be UTF-8. So utilize your memory. One reason why I focus on memory is because MySQL doesn't have a limit on how much memory the process stack uses. So per connection and temporary tables on top of the default buffers will utilize memory, and there's no sort of cap or limit. You need to make sure you keep an idea in monitoring your system's amount of memory. In a similar way, blob and text fields can be very inefficient in 2 areas. The first area is that people who lazily go select star to select data, when they don't actually need to select all the data, and depending on queries may use temporary tables, which you would think would take memory, but because the memory storage engine can't support that, it's actually written to disk, so it actually slows down the process. It increases the amount of traffic that goes across the network, which is another potential I/O bottleneck. And internally in InnoDB historically, and I say historically because upcoming patches have been changing things, the way in which multiple text blob fields are stored in InnoDB are inefficient and create additional data pages and actually then additional data seeks, which is disk seeks. As I talked about before, minimize your disk access, which is your slowest physical performance. Another thing that I would like to pass some comments on is about indexes. And I think everyone here would understand the benefits and the pros and cons of indexes. There are good reasons to use indexes and there are poor reasons to use indexes. you know, one of the things to focus on is don't use indexes excessively because they actually slow down your system. They increase the size of your database footprint, which can potentially increase your backups. And if indexes are used sporadically, then they actually increase the use of memory. So one thing you want to do with indexes is look at minimizing internal processing that take up the use of memory. One of them is using temporary tables. Various SQL statements will use temporary tables. Certain SQL statements with joins or subqueries will use multiple temporary tables per SQL statement. That is memory that is allocated on the connection, and that memory stays with the connection until the connection is exhausted. So in an environment where Java, where you use persistent connections, that memory is not released. And then also, if you actually structure your index as well, sometimes you can eliminate file sort. And file sort doesn't seem to be sometimes a bad thing, but when you can actually find that to be a limiter when a lot of your queries are doing file sorting, and depending on how optimal you choose the columns that you select and what indexes you have in place, eliminating a file sort would be a great thing. One thing, particularly from people who don't come from a MySQL background, they realize the fact that they don't understand the concept of a covering index. So by looking at the SQL that you are running and looking at the concept of a covering index, you can actually reduce the overhead of not being able to look internally in MySQL, both within InnoDB and also within MySQL for different storage engines, of being able to do lookups on your index, then random disk seeks to do lookups on the data that you want to retrieve. Sorry for rushing, but you know, I really had like 25 minutes, wasn't it? So it's a speed session. SQL. This is something that I'm very passionate about because I believe I'm a data architect, and I believe this statement: developers don't write proper SQL statements. And at least one person is awake because he's applauding. SQL developers are focusing on delivering functionality. That's their role. That's great. But as most people here, if you're a developer in the room, you have to be a good steward, because unless you have an architecture where there's a database administrator or a data architect reviewing your work, you have to look at your SQL statements. Very few, in fact, I've only come across one client who actually looks at every SQL statement they have that goes against the server. When I look at performance problems, it generally comes down to looking at the SQL statements, and looking at the slow query log is generally not the cause of the problem when someone has done some tuning. The problem is a very efficient query that is running an excessive number of times. So 1,000 queries that run, for example, in less than the time that your slow query log runs, you'll never actually see them logged in the system. So knowing every SQL statement that runs against your database is important in your architecture to make sure that you've actually designed it correctly. But what you really need to do from a capacity planning exercise is also monitor those SQL statements. You need to look at the explain plan of those queries. You need to look at the time that the query takes, the number of rows it produced, and also, more importantly, the size of the result set that is being returned to the client. Because if your data grows over time, then the queries will get longer, the amount of data will get longer, the increase in the network load will become more. So any good stewards in terms of monitoring, you start at one point, but you want to be able to trend that information over time. These things are difficult to get out of MySQL by default. MySQL Proxy, for example, is a good tool that enables you to gather this information. Load Balancer, which is becoming available as a commercial product, is now offering this type of instrumentation, which is really good to the end user. From a consultant perspective, we've been doing this for years in black box type methods to actually look at SQL statements to improve them. And as I say there, you need to review these things because things change over time. So, moving right along to what I love doing, which is looking at data. Just a couple of points in terms of looking at architecture. In a MySQL perspective, I believe in the principle of sharding. No matter what type of architecture you have, I think you should consider sharding from day one. That means look at the environment that you have. What is going to happen when you are massively successful? How is that going to work? You know, people go backwards and forwards on top of this, but I see lots of organisations now that sort of have one master and like 10 or 15 slaves. They don't want to move to the sharding process, but if they'd actually thought about it earlier in the piece, they would be actually able to work ahead much better. With sharding, there are two fundamental factors that you must look at for it to be a success. Number one is choosing the right partition key. And quite often this can be an almost impossible task. And what generally happens if I talk about sharding in more details is I can explain all of the bad examples that I've seen for sharding. The best I've seen is at Photolog, where they decided to shard by the first letter of username. So they ended up with 26 letters and 10 numbers and one extra. So they had 37 different shards. The problem is that more than 50% of their users actually come from South America and they all start with M. Doesn't quite work too well. So choosing a mutation key is really difficult to do. And then the other critical component of that is being able to rebalance. If you have shards, being able to rebalance your data. Tricks to doing that is identifying your data across all the different relationships and parent-child data. You may choose to use a programmatic key, like a modulus on a number, to choose how to shard your data. The issue with doing that is as your data grows, then if you decided to start with 2 shards or 4 shards, then you have to rebalance the entire thing. And I coined a principle that I use with a client. A way to get around that is to come up with the concept of virtual hosts and physical hosts. Decide to come up with 1,000 shards, but only start with 2. Virtually you have 500 on each one, but physically they're assigned to hosts. And when you want to actually increase your physical hosts, you simply introduce a new physical host and change the relationship between virtual and physical and rebalance just those ones to the physical host, and you're operational. Another thing that I find a problem, again, maximizing the use of MySQL and minimizing its weaknesses, is looking at availability of data. The biggest issue with MySQL is it doesn't provide online maintenance of tables, altering columns, adding indexes, except for the most recent releases. So to circumvent that, a popular thing I use is introducing master pairs. We have a pair of MySQL servers, a master and a failover master, and you will fail over appropriately, do online maintenance, let them catch up and repeat the process. Another way to consider that is to identify whether there is a way in which you can make your data available to your end users in a certain means so that some functionality may be restricted for a portion of time to do maintenance. So by doing that, if you introduce a messaging system that identifies what data is available in a write mode, which means the master, what data is available in a read mode, which means you can only read it from the slave, and then being able to partition that down into actual certain petitions within a table when you have a sharding infrastructure, then, for example, a system that has a system where you can log on, you can then upload photos, for example, or make comments. If you want to make a change to the user's system, then what happens is that you can actually mark the user's database or the user's shard as read-only, which means that you can modify the master, so that users can log in, but they can't, for example, change their preferences. The application could report, okay, this piece of functionality is unavailable at this point in time, but to the end user, the entire site may be available. And if you have actually sharding that out, then you may have a certain portion of data unavailable. So being able to introduce this way to be able to notify the application of certain availability of data, it means your system can appear to be operational, and for most users it may be operational, rather than bringing something down from a maintenance perspective. And to sum up with data, one advantage is to look at your data now, particularly as I'm spending more time investigating other technologies of using cloud-based technologies, exploring with Google App Engine, SimpleDB, moving data from online data center positions out to the cloud processing or other options, is the purpose of being able to synchronize the data that you have in the database to certain functionality. And the easy synchronization trick is to look at data which is write once data. If you can take data which is write once, which means that you don't update the data, then it's very easy to actually petition that in a certain way that your application requires. It enables you to cut down on the backup of that data because you only have to back it up once, you don't have to back it up every night. It enables you to synchronize that portion of data very easily with external sources, particularly if, for example, they're not MySQL data sources and your application is trying out new technologies, for example. And this enables you, with certain portions of data, to try MySQL and non-MySQL. Now, write once data can be a tricky thing. Again, this is a concept of looking at the application needs, a little bit like the messaging system I was talking about before. You may have to sacrifice in your application, for example, 2 lookups of data as opposed to 1 to improve availability. With write once data, it may mean that you might have to write to 2 tables rather than 1 table. It's a big thing to consider, but if you want to look at large volumes of data, you want to be able to spread that data across different systems, you want to, for example, do data warehousing and reporting across historical data. If you have one table which is always written to, but only just updated to update a status of a column for something, if you consider breaking that apart, you may actually find the ability to be able to manage your data, to be able to separate your data across different nodes, to be able to partition data in separate tables, which cuts down the ability for the increase of maintenance time. These can actually provide a benefit. I'm actually ahead of time. I think I'm doing well. I rushed through those a little faster than I thought, which is good because Peter's coming soon. So in that regard, as I mentioned, I'm an independent consultant. I'm a gun for hire. Having worked at MySQL, I don't need to toe the party line anymore, so I can recommend Percona patches or Google patches or non-MySQL products. I focus on performance and architecture, and I'm available for any work and or right now any questions.
We might take questions offline.
Okay, we'll take questions offline because I rushed through them to try and catch up a little time. So, thank you.